Okay, it's 5 after 2 p.m. and let's start officially this webinar. Again, hi everyone to today's webinar, 3D Survey, what's new in 3D Survey 2.17. My name is Marco and today is also Matthias Zupan with me, our Quality Assessment Manager. We will try to present you the top features of latest version 3D Survey 2.17, which was released a bit more than a month ago. Yes, today we would like to show you what's interesting, what we achieved, and so on. If there are any questions, again, please feel free to write them in question box and we will answer them during the webinar or at the end of the webinar. If we go and have a look, what kind of topic we would like to see today is the first point, what's new in 2.17. 4 strong points. The first one, the strongest one, definitely new texture algorithm. If you already downloaded the version and check it out, hopefully you're satisfied with the new approach. It's much faster and everything. Mattia will explain later in details what we achieve and what are the benefits of new algorithm. Then the second improvement, which is directly connected with the texture, is better through Orthophoto. I will try to explain you those benefits. Then again, Mitya will explain you the third strong point, align two objects based on identical points. And last but not least, the C shortcut capture improvement, where you can export a screenshot from 3D Survey directly in an image. And of course, also at the end of the webinar, there will be enough time also for questions and answers. This webinar should take about 45 minutes up to 1 hour, depends on question you have and so on. And before we actually start with the main topic, I would like to launch 3 short questions from the beginning. And the first question is, which industry do you work in? So please feel free to set your answers inside that we can see what kind of audience we have. Okay, more than 55% of you already voted. Let's wait a couple of more seconds and feel free to set your answers. Okay, 70% of you already voted. I will close this first pool and we can see results already. So 75% surveying, 13% construction, and 10% other. Okay, let's launch also the second question. The question is, what is your job role? So are you engineer, are you manager, leader, owner, or other? Feel free to set your questions. Again, more than 65% answered this question, 70%, few more seconds. And let's close this pool. Okay, so we have here 47% engineers, 29% owners, and 60% other. Thank you for this answer. And the last question in this session, are you already using latest version 2.17? Okay, looks good. Okay, 70% already voted. And let's close also this poll and thank you for your answers. And we can see 57% already updated to 2.70 version, 24% no, and 90% I'm not yet a 3D Survey user. Okay, very good. Thank you for those answers, and let's continue with our webinar. And first we have a PowerPoint overview of new functions in 3D Survey 2.17. And first, the most stronger one, and definitely it is a texture improvement of our latest version. What was actually the goal before we start with this improvement is we were aware that we need speed improvements because calculation of textured full 3D mesh with the texture took quite long. So in the old solution, we need from 30 minutes to 5 hours on an average data set on an average computer. And our goal was to improve this to make this algorithm much faster. The second strong point is because most of our customers are surveyor, construction, miners, architects, and they are doing a lot of vectorization also inside of 3Dsurvey, or they export the data in other CAD software and do the vectorization. We know that we need the full resolution on textures. So input data as image, resolution should be the same as on mesh resolution. So this was our goal to achieve, that you will able to see clearly road marks, curbs, manholes, building corners, or anything like that. Old solution for texturization did a lot of blending. Also, other competitive softwares are doing a lot of blending, and with the blending of more images one over the another, you lose detail, you lose this sharpness of main resolution, and we would like to be here different, more accurate, more precise, and so on. Then the texture algorithm should calculate also bigger data sets, 5,000 images plus, and so on. And we know that the old algorithm was quite hardware consuming, so you need 128 gigabyte of memory if you have 3,000 plus images. And we like to improve this one, and this was the main vision for improvement. And what we actually achieve, can Mattia now present you in a short PowerPoint, okay?
Okay, thank you, Marco. I hope the sound is good. Yeah, as Marco mentioned, we worked hard on our new texture algorithm. And its biggest benefit is the speed we get, because it is really significantly faster than the previous algorithm. So down here you can see the table, which represents the time needed to calculate the texture in the old algorithm and in the new. The new one is in the red, the old one is blue. As you can see down there, these are 20 data sets. They have been calculated on different computers, more on that later, because the benefits depend on your hardware, of course. But generally, you can see that in every test case, the new algorithm was significantly faster, on average 3 to 10 times faster. And now, as the parameters that affect the speed of calculation concerning the telemetry, or the way you took your photos, are following. So if you are using more oblique images, so let's say not only top-down nadir photos, and if you're using different sources of your images, if you're combining two sources, for example, the old algorithm was really slow on that. So there are the biggest improvements. So if you're flying some free flight missions or oblique missions, this is now greatly improved. And as Marco mentioned, on average, the data sets, like average data sets with a couple of hundred images, now take about 15 minutes to calculate. We had also data sets with 1,000 and more images in those tests. Those are the highest columns on the graph. and they are also significantly faster with calculation. So this is general idea. Yeah, this is the presentation of how the same data set was calculated on different computers. And let me explain it a bit more. The first PC is an old computer that is about low to mid-range computer with let's say about 5 to 6 year old hardware, and it took a lot of time before. It still needs quite some time to calculate the texture, but just a quarter of previous time. PC2 is one of the fastest computers we have in house, so it calculated texture quite fast, even on the old algorithm, but still quite the improvement with the new one. And perhaps the greatest improvement of them all is on laptops, because laptops are usually equipped with SSD disks and multi-core processors. They get very much benefit. They benefit most and have a significant cut in calculation time. Okay, if we continue, I'll give the word back to Marco now to explain a bit more.
Thank you, Mattia. Yes, so this was the first one, really strong one, speed improvement for texture calculation. The second goal, as I mentioned already before, is texture with image resolution. So on the screen you can see on the left side actual image from drone. I think it was Mavic 3 Enterprise, and on the right side you can actually see already calculated 3D models. And if I would zoom here inside, you could probably see that the resolution of the image is the same as resolution of a texture calculated on mesh actually. So we try to find the best image for texturing, which was the closest one, has the best resolution. We do all the colorization, everything like that, and try to achieve the best results with this. And what should give you this is when you're connected CAD lines or anything, any extraction based on texture 3D mesh, you should be now more confident. You should easily extract out building corners, manholes, position of road marks, curbs, on anything like that. So the model is super sharp now with the new approach, and I'm sure you should be satisfied with this one. Yes, here you can see also comparison before and after. So with the 2.16 version, we had some artifacts and the texture was not so clear. With the 2.70 version, now the road marks and asphalt and all the surfaces are much clearer. You see there is some kind of a ghost effect of a traffic lights in the previous one. Because we now improve the algorithm with additional improvements. We actually know on which triangle which image comes and everything like that. Then another improvement of texture is before, if you didn't have an image which covered specific triangle in mesh, we leave it as a black color. With the improvement of 2.70 texture improvements, we also calculate the color of triangulated mesh where we don't have any image. So we try to average the vertex colors and put those colors to triangles without the image selection. And this also gives a better feeling to end users. If you share your results, those results should look nicer and actually much better in comparison to the previous solution. Another nice improvement I would like to share you also in the later presentation, where we go and check it out what are the improvements on true orthophoto, is we eliminated automatically ghost effects. So on this area, you see a road where a lot of cars were driving during the mapping, and because of blending, the old algorithm, we blend them all together, and then you get some kind of ghost effect on the road. As you can see, cars are some were visible, some were not. With new improvement and new texture, we eliminate this effect 100%. And as a result, the true orthophoto is much nicer, texture is much nicer, and another great improvements which comes with this improvement. I will also share this experience later again. And now, Mattia, feel free to continue.
Okay, thank you, Marco. Well, as we left on the hardware before, so let's take a deeper look into what this means that this new version is lighter on your hardware. Because it needs less RAM, the minimum recommendation, minimum hardware that you need for running 3Dsurvey and calculating 3D models is now actually lower. So you don't need as much RAM as you did before, because the peak working memory is can be also 10 times lower than before. You may have, if you have been working with large data sets, you may have encountered the anomaly error like shown on the image on the right, where you ran out of RAM and that was the result. You know, you couldn't get the whole texture done because there was simply not any memory left. And now we have eliminated this error, so you can work on projects or with the number of images that was previously impossible for you. And another nice feature is also that texture now is compacted in a smarter way, so it takes less space on your hard drive. This means, well, you save the hard drive, you know, we all run out of it eventually. This new version will save you about 10 to 15% of space that was occupied for the texture. And another nice feature is also that when projects get bigger and bigger, meaning you input more images or you calculate models with more triangles, it doesn't slow or prolong the process exponentially. It just linearly prolongs the time needed to calculate texture. So don't be afraid to input 3,000–4,000 images or to calculate models with 10 million triangles. This is all good now. The bottom line here is you can expect higher stability when doing texture calculation. If your computer was crashing with demanding data sets before, you are now safe. And okay, we can go on to the next slide, where I will show you a bit more about the CPU. So if we were talking about weak computers before, we can also say something nice about modern good computers. As I mentioned before, significant improvement comes for laptops which are equipped with SSD disks and multi-core processors. Parts of operations that are carried out to calculate texture were not optimized entirely or properly before. So that means only one core was doing a lot of calculations, as you see on the image on the left. And now we put to work all cores of your processor. And this is where a lot of time saving comes in. And as I mentioned, the speed that we get is also attributed to the usage of SSD disks, which we now utilized better than before. Okay, and another visual element that is now improved is the contrast. Let me just click here. And you see, now we get much clearer image, getting deeper shadows and more radiant highlights, which enhances visual appeal of your 3D models. That's, as Marcus said, you can present the end result to the end user much more confidently because it looks so nice. Okay, Marco, I think we're back to you now.
Thank you, Mattia. So if there are any questions, feel free to set them in a question box. Otherwise, I would like to continue with better true orthophoto. So before we try to explain you the benefits of true orthophoto improvements, I would like to show you the workflow. So how you actually calculate the true orthophoto. And if you start with images, the next step is bundle adjustment, then dense reconstruction, and then you have, after you have the point cloud, you have two options actually. You do the classification of the terrain, where you eliminate, let's say, houses, buildings, trees, and everything else that you have just a surface model. And then with the terrain points, you calculate the regular grid mesh. And with the regular grid mesh, you are able then to calculate traditional orthophoto. Okay, so this is one option. Actually, to achieve the traditional orthophoto, here is some manual work needed. So you need to classify the point cloud. This cannot be done yet automatically. And at the end, you get a traditional orthophoto. And before we continue, I would like to mention just some advantages and disadvantages of traditional orthophoto approach. And advantage is actually there are no artifacts. So you have super sharp roof edges with no artifacts. The calculation is faster because you don't need to calculate before full 3D mesh. So you're calculating the traditional orthophoto with a regular grid mesh, which is kind of super simple. And this also means you need less hardware. This is less hardware demanding. So if you have super big data set with 3000 images plus or even more, the algorithm can also easily cover it. So these are advantages. And what are disadvantages of traditional orthophoto is that entire building needs to be on at least one image. So this means if you're flying low or you have huge objects like big holes or something like that, you will probably not going to get the nicest orthophoto from those results. So if you like to have nice traditional orthophoto, the complete building needs to be on one image that we can then texture bigger area with this on image, and then you have really nice roof edges also. The second disadvantage of this is that the roofs and similar objects that are pointing out from the surface are actually not on the correct coordinates. So it means the traditional orthophoto looks nice, but if you would like to measure the position of roofs and objects which are pointing out from the terrain model, you can't, okay, because the position is not accurate. Okay, so you need to understand this one. So with the traditional orthophoto, everything is on the correct coordinate, what's on the ground, so what's on the terrain surface. Then another disadvantage of this approach is you need nadir images. So all camera needs to point perpendicularly down. So let's say you need to fly a single grid mission with 90 degrees camera angle. Otherwise, you are not able to get a nice traditional orthophoto. And we know more and more provider of drone solutions force 3D flights. So like a double grid mission with a 70 degrees, minus 70 degrees camera angle. And in this case, to calculate out traditional orthophoto is just not possible. Okay, so as we can see, you need to know which one orthophoto need on which situation. I would say if you have open areas like a stockpile or like a, I don't know, big area with no buildings and anything like that, the traditional orthophoto is fully enough for you. It's quick, simple, and actually the nicest one. But in case you have a lot of buildings and you would like to get a nice 3D model and accurate position of roofs, then you need to go and check the another approach, which is kind of a true orthophoto approach. And if we check again this diagram, due to the dense point cloud calculation, the approach is fully the same. Then you skip the classification and you go directly to the second option, which is calculating a full 3D mesh with texture. And we actually improve part of this process. So as you can see, here's the first step is mesh calculation. It's still the old one, but we improve the texture because this was the most time consuming part in the old version of 3Dsurvey. And when this calculation is finished, we just simply look the model from top-down view and we create a true orthophoto. Okay, and with this true orthophoto, you actually get an orthophoto. Okay, no artifacts, I think. Sorry, let me go back one step. Okay, need to go that way. So what are the true orthophoto advantages? Sorry, I don't have the right slide. It looks like I missed the table somehow. Okay, don't look on this text. I will try to explain it. So what are the benefits? Okay, let me do different way. Let's open this one. Okay, cool. So tips and tricks a bit. So with the true orthophoto, you actually have the roofs and all other objects on correct coordinates. Okay, so if you need to measure the distance of the roof, you need to have true orthophoto. If you need to measure the relationships between the roof, end of the roof and road or something like that, the true orthophoto can give you also these results. So any detail on orthophoto, it's actually on the right coordinate. Then another nice advantage of true orthophoto approach is the process can be fully automatic. From images to orthophoto, it's fully automatic because you don't need to do classification in between, which is kind of a semi-automatic work. So you can use bundle adjustment in 3Dsurvey, import images, and the calculation can finish with orthophoto. Then the true orthophoto option gives you also a custom plane orthophoto or side orthophoto. Okay, so if you have a, I don't know, building facade and you would like to create an orthophoto of this facade, you can easily do with a side plane orthophoto in 3Dsurvey. And another nice benefit, which is more and more important based on user feedback, is with a true orthophoto, you can calculate it actually from any type of images. So support of nadir and oblique images in a single project, it's not a problem. Okay, actually, the more you have oblique images, the better the end result should be. But also just with nadir images, you should get a nice true orthophoto if you're interested just for orthophoto. And if we take a look of disadvantages of true orthophoto, definitely we must say that we still have a bit more artifacts with the true orthophoto in comparison to traditional orthophoto, because the artifacts mainly depends on the mesh quality, and the quality of a mesh, it's still super difficult to get the perfect boundary between the roof and terrain, to have the roof as I don't know, in a straight line. It's super difficult, and then you have some bubbles, and then based on this, we get some artifacts also on the Orthophoto. Another disadvantage is because this algorithm for textured 3D models and also for mesh calculation, it's much more harder, so it's more advanced algorithm. Definitely enormous, huge areas, the calculation will take longer, and maybe you will need to split super big projects into two areas or something like that. Okay. We improved this quite a lot, as Mattia already explained, but definitely with the traditional orthophoto is this much simpler. Okay. Cool. This was from my part. I think Mitya is back on.
Hi. Okay. I guess it's enough of the texture. Let's move on to some new features. So let me show you the first. Let me show you the video of the new feature called the new transformation alignment tool. Okay, can we see this video? Okay. So, I guess here, I guess we have some problems with this video. Perhaps we can view it in the presentation. Okay, I guess we'll just skip the video. Sorry about that. And we'll go straight to the to 3Dsurvey. So let me just, okay. And can we see the 3Dsurvey screen now? Okay, now what I wanted to show you is the new transformation tool upgrade that enables you to align two objects that share at least 3 identical points. So how does that work? Let us first see the scenario where this would come in handy. Let's say we do a 3D model of this dam. It's pretty easy to do it with a drone, but if we wanted to get some more details on the part down here, it is pretty hard to map it with a drone because we need to fly very low. You see, these cameras are already quite low, and there are some trees here. Maybe you don't want to get too close with your drone. That's not so cheap. That's why you can do this part with your phone. So in this case, we did some videogrammetry of the lower part of this dam, and we got a separate point cloud, which I will now zoom into, and it is here. But the problem now is that these 2 point clouds don't fit together. But we presumed that this will happen. So one thing we can do, we can use our ground control points. It's not necessary, it's just the best practice and probably the easiest one. And we can map them in 3Dsurvey. So we click on them and make them CAD points, and then we will align those points on point cloud 1 and on point cloud 2, and they will fit together. So if we look at this second point cloud for a second, we can see the detail. The inner part is much better. Okay, now let's go through this process. We will start in our drone point clouds. We go to our CAD tab, and create a new layer. Okay, there's a new layer, and we'll call it drone. And let's give it red color is good, make it active. And now we have to make sure that those points that we're going to mark are visible on both data sets. So I'll find this target down here, click on it, and if I'm not sure that this is the center, I can still help myself with some drawing on images. Zoom in here, okay, then center. Okay, second one. Same process, click, let's make sure. Okay, perfect. No additional work needed. And as I said, we need at least 3 points for this to work, but you can add more. But this is just a tutorial, and I'll just put in 3. So, and I've done my drone point cloud now. And for the second point cloud, you need a second CAD layer. First, go to zoom to your second point cloud, and now repeat the process here. So you make a new CAD layer and go through these targets again. Well, I have already done that, so I'll just turn on this layer. Hope you don't call me cheating for this one. And as you see, we have same targets with same names on the marked by same points. Well, points on different layer. So now I want to transform this second point cloud onto this one. And I do this with right click and choose transform. And since 2.17 version, there is this calculate parameters button down here. One more thing right here before we go into, don't have this one on. So uncheck the apply transformation to project, because this would mean that you would also transform everything else, even the second point cloud. So you just want to transform this one point cloud, nothing else. Okay, go to calculate parameters, and now pay attention. First, we choose points from which we want to make a calculation. So from videogrammetry to drone. That means we will move from this to this. And let's stay here just for a second. In the middle, you have error calculation, and these numbers should be relatively small. So you see this is in meters, and these numbers are all below centimeters. So this is perfect. If these numbers would be larger, the text would turn in red, and you know there's something off. It's better to repeat the process or check the points. If you're doing this, make sure the numbers match. Usually when we're doing CAD points, they often enumerate, so they go from 1, 3, 4, 5, 6. So if you would, for example, have this one 4, now it doesn't match. Now it wants a 4 here. So let's just make it back to correct number. Okay, everything is okay. I click calculate, and already my point cloud jumped down here where I expected. Okay, so I can make sure everything looks as I want it before I even do the confirmation. I can rotate the screen, I can see how it transformed, I can even turn off, on and off the point cloud. But let's just confirm, because it looks good. The bounding box is gone, and now I can see the combination of two point clouds. Let me just show you the difference. So if I turn off the second point cloud, you see this is much poorer point cloud now. I can't see the walls in here, and now I get everything. I can see these wooden parts. No, I can't. And this is just one application of this new tool. You can use it also for different scenarios. For example, if you're using the terrestrial laser scanner and you have multiple standing points and your scans are unorientated, you have to manually match them together. Make sure that every scan catches at least 3 points where you orientate and connect it to the neighboring point cloud. You can also transform between coordinate systems. If you have some points in one coordinate system and a point cloud or a mesh in other coordinate system, you can simply transform the object, it can be point cloud or mesh, to the coordinate system of the points that you wish. So, and this is one idea that comes to mind is also you can now do scans of inside and outside of houses. You know, you can do photogrammetry on the outside, laser scan on the inside, have some tie points and connect it all together. I think this has great potential. We have yet to see what beautiful 3D models come out of it. So I hope you find this useful. And if you get some nice 3D models, make sure to share them around so we'll be able to see them. Okay, I hope you like this one. There's also one minor update. That's also quite nice. That comes with the 2.17 version, and I will present it also on this data set. And if you remember the last time we had webinar, we presented the snapshot option. If you press C, the program will create a snapshot of your rented area, which is exported into PNG, and you can share it right away. It's the fastest way to share your work in 3Dsurvey. But if you remember, previously you could only have one, and if you made another one, it just overwrote the previous one. But now we have made it a bit better, so you can turn on and off various stuff. Make one with this point cloud and one with both, and all your snapshots get saved in here in your working directory. Another thing that we can also tell about this is now it's in PNG, which means better quality, and it also has timestamp, which comes handy sometimes if you want to remember when you worked on a specific project. And yeah, this is all about the this little functionality. It's not much, but it's really nice. I hope you like it. And yeah, Marco, do we have something else to say?
Yes, so what I would like to share is additional presentation of ghost effect, and maybe in a bit of different way. Hopefully you can see the screen already now. You should see our 3Dsurvey cloud beta version. It's kind of a cloud platform for sharing data and project management. And here you can see our split screen, so it's kind of a time comparison, and I just use it to show you the old version of Orthophoto Let me just wait that the refreshment came to the end. So here we can see now the full resolution, and this is the old orthophoto, and probably you can see he's here ghost driver, which is visible in orthophoto. And if I go with the slider to the left side, now the new orthophoto algorithm is coming out. Actually, new texture algorithm is coming out, and also as a result improvement of true orthophoto, and there are no more ghost effects. Okay, we can still see those artifacts which are results of true orthophoto. So this is because this is the result of mesh calculation. So what I would like to mention here, we still have some homework. So we improve the mesh texture, it should be nicer and everything like that. So our next step is also definitely also the better mesh algorithm, which then generates also more accurate edges and so on. But this is next step. There's always a lot of work to do, no problem. But again, here on the left side, let's move it like so. If I zoom again here, if you are mapping over the urban areas or over the road areas, also competitive softwares, they still have these issues with the ghost effects where the cars is more times on the road. With the 3Dsurvey 2.17 texturization, we fully limited this artifact, and the orthophoto is from this reason even nicer. Okay. Okay, and let's maybe quickly review what we've seen today on this webinar. So we see the new texture and what are the benefits and everything what comes with it. We see the better true orthophoto improvement because of the new texture. Mattia present align two objects based on identical point tools. Also super nice, exciting features, which can help in a number of different scenarios, and the C button, C shortcut capture improvement. And I think those are all main topics right now. So I think, yes.
Why did you tell us about the cloud? This was a bit of a surprise. Care to tell us a bit more?
Yeah, because it's still in beta, it's coming. So maybe for the ones who would like to check it out before it's official, feel free to send us an email that you would like to check it out. We are ready. We are already in beta testing step. We are sharing this cloud platform with our beta users. So if you're interested to see and to check a bit more, you just seen a part of this one inside, but it's kind of a complete project management tool where you have all the projects, where you can see your projects and a map view, then also as a timeline and so on. So it's a super nice thing, but it's coming, so let's wait a bit more. Okay, and definitely then when this will be ready, we will be more than happy to share those infos and also platforms with you to give some feedback and so on. So definitely. Okay, before we go to questions and answers, I would like to set you a few more questions in our pool system. So let me just find the pool option. Where is it? Questions. TV is Mattia. Okay, looks like it's gone away or something like that. Maybe I close the pool and I close the Okay, maybe in meantime, when Mattia is trying to get the pool back, we can check some questions. We definitely have some. So if there are some in addition, feel free to write them in the question box, and I will start with my questions and answers. So
I think the poll is now open.
okay, cool, very good.
Click away.
Very good. Then let's start with two last questions. So the first one is from 1 to 5. 5 is excellent. How would you rate this webinar? So please feel free to set your results.
Thank you for those ratings. Looking good.
Okay, Mattia, you can maybe close this one if most of them already answered, and then set another more question. Okay, so what is your favorite improvement? So the ones you see, actually, the first one, new texture, the second one, improved orthophoto, aligned to object based on identical points, C capture, and cloud beta was just for fun. Let's see what kind of answers we can get from you. Mattia, how far we are with answers?
We have 69 people voted. Let's just wait. 70. Oh, right. We're on 70%. I guess we can close that and move on to the next one.
And that's it, I think. It's the final one. Do we have results maybe?
So yeah, the results now are 16% like the new texture and 35% of people like improved orthophoto. 44 answered for align with object with two identical points, two objects with three identical points, sorry, and 5% like the C capture best.
Okay. Thank you for those answers. Let's go directly now to your questions. And the first question from Dylan Robbins was, is there an easy way to fill a hole in case the algorithm doesn't fill it? Okay, so the question is connected with the mesh calculation. Yes, so we improved the texture algorithm. The mesh is still the same. Our next bigger goal is to improve the mesh calculation. So in a 3Dsurvey future, this will be covered automatically. No, if you don't have a point cloud, then the algorithm doesn't calculate also mesh on this area. There is kind of a hack. Maybe I can super quickly show you just a solution. Let me try to, for example, if this is my model and I would need also mesh from this side. So the first result is like so. I would like to improve this one because I need also mesh from this side. Maybe this is one option. So you go to cat, create a new layer, get some color like so, and it's kind of a combination of multiple functions. So I'm kind of creating a closed polygon of this area, and then the third option for mesh calculation is triangulate mesh from CAD data, and I take just my mesh, and in this way I create actually a new surface. And then what's possible is right mouse click, convert this surface to point cloud. Let's take 1000 points per square meter per meter, calculate, and then in this way you actually create points where you didn't have them before. And now if I go and calculate this mesh, not colorized, so just super quickly mesh calculation, I should get then also mesh from this part. Okay, so it's maybe not the straightforward workaround. If you really need this one necessarily, you can do it that way. Okay, and yes, let's continue answering other questions during this is calculating. Second question from Evan's Courier. How do I calculate the texture space? Okay, so probably if you have wholesale textures or something like that, is Evan's questions. So with a new texture, if you don't have a specific image to specific triangles, we try to average the color. So this should be solved immediately. If you don't have a mesh, we cannot calculate texture on that area. So this is as it is. Okay. Okay. Hopefully, I answered this question. Then another question from Dirk Elsbeck. Does it make sense to recalculate old project to improve the results? Okay, good questions. Actually, you could do that. Yes, no problem. Right now it's still calculating this one. Let me open another parallel on.
Especially if you have like ghost effects on your old calculated mesh, you can now repeat the process with the new version, and it will be, as Marco showed, a lot better looking.
Okay, so for example, this is my old texture. What you can do easily is just right click on selected mesh and calculate texture. And this will actually again calculate new texture with the latest algorithm. So other option is if you like to include old texture, what you could do is right mouse click and click on simplify, and you actually simplify this mesh, and you can take, let's say, the same number of triangles, just type it here, 3.5 millions. Okay, let's take 3.4 millions and click on simplification. You can lower the number of those triangles, and now this new one, let's save it as new. This is kind of without texture. So if I compare it with the new one, old one, and again, right mouse click, calculate texture, and just click on calculation. And actually, then you can have those models at the same time on the same project. Okay, so super easy, and it's kind of reasonable if you need this, no problem. Okay, let's continue to next question from Martin. Hi Marco, may you can show the workflow how to get a vertical orthophoto from a facade? Sure, no problem. I already have the right project. So when you have texture 3D models, to calculate orthophoto, go on Orthophoto, and then you have two options. So calculate new top-down orthophoto. This is for true orthophoto, and then the custom plane orthophoto. And for facade orthophoto, take this custom plane orthophoto, go to the left lower corner, go to the upper right corner, and try to put this orthophoto bounding box on the right location. Then you can improve this position with the right mouse click on a plane of this bounding box, like so and so, to extend it. Also on the right side, also on lower, a bit down. If you're just interested in facade, this would be good enough, like so. If you would like to have also, let's say, a roof from this model, extend in a height, and also you need to go here to back, like this. Okay. And now actually everything what's interesting for me, it's inside of this bounding box. This orange surface needs to pointing from the face side, okay, because here we are doing kind of a capturing. Then what's super important, manually set resolution here. I will leave now 1 centimeter because it's a presentation. I could give here 2 millimeters or something like that, and just click calculate, and the calculation should be done then in a second. So here we already have one. Okay, saving file. In addition, just a second, autosave is on. Okay, maybe I run out of memory because I'm processing few things in addition here on the backside. Let's stop this one if it helps. Okay, and in this way you can actually calculate the orthophoto also from the facade or custom plate orthophoto. Okay, let's continue and come back then with this one. Okay, then another question here. How do you transform the coordinates from UTM coordinates to Gauss-Krüger coordinates? Okay, really good question. Really good question. Also, this transform tool, which actually Matthias shows you how to combine two data sets, could help you to do this. Okay, you just need to import identical points from UTM and identical points from Gauss-Krüger, and this should be easily matched together. Okay, so as you know, it's not possible to change the project coordinate system in 3Dsurvey. So you define the project coordinate system right at the beginning, and if you didn't select the right one, you cannot change later on. So for example, if you set the UTM coordinate system in 3Dsurvey, you cannot later go to Gauss-Krüger. That's why we put this feature also inside, that you can actually then transform point cloud or transform mesh, or even later also orthophoto in Gauss-Krüger with these options. So just click the import. You first need to import Gauss-Krüger points in 3Dsurvey as a cat points, then same points as a UTM as a cat points that you have two layers, and follow the Matthias workflow, and you will actually transform those coordinates. Check it out and let us know if you need some additional help. Francisca, yes.
There's a tutorial already online on our YouTube channel that explains the workflow. I also did today on exact same data set, so you can also watch it there. It's a bit more edited and less review, I guess.
Okay, before we continue, here we have now the results of the facade orthophoto as I defined before. So you can see it's kind of a nice side orthophoto or facade orthophoto where all the details on it. Okay, if there are some questions in addition, feel free to set them. I think we have here another one. Will there be a chance the 3Dsurvey can run on Apple M2 processor device? Would this be a benefit in matter of speed? Yes, so currently we support Microsoft devices. Actually, the environment is ready also that we could support the Apple, but it's not in a short-term plan. We are going this way, but definitely not in next year or something like that. In sometimes we will support this one, but I'm not sure if you would benefit so much. I know they have a new processor devices and graphic cards and so on, but we do the comparison, and with a ordinary laptop or ordinary desktop computer with the right specifications, you can definitely compete also this one. So check out computer specifications which are best for 3Dsurvey, and I think you are comparable also then with the Apple M2, no problem. But yes, it's the vision goes also in this way. So in long future also to support Apple devices also. Okay. Mattia, would you like to add something in addition before we close this webinar?
Maybe just something like a warning. If you install 2.17 version and run into some problems with bundle adjustment or dense reconstruction, Please make sure you update your NVIDIA graphic card drivers. It's very important because we did some upgrades in environment, and the older version of the environment are now deprecated. So you need the newer drivers to work properly.
Cool. We actually had one more question, so I just skipped this one. But okay, for next time. Yes, then let's say thank you for coming to this webinar. Thank you for attention. And as already mentioned, recording of this webinar will be available also for those who did not attend to this webinar. And if there are any questions or something like that, feel free to contact us via email, Facebook, Instagram, other channels. And if you have some feedback about the texture or anything like that, the features you just saw today, feel free to send us your feedback. Okay. Thank you for coming and happy 3D surveying.
Enjoy. See you next time.